Module 4. Global Zero Touch Provisioning. Module Objectives. In this module, we will understand an overview of the global ZTP process. What are the prerequisites that have to be in place? Scenarios where we can use the global ZTP method to onboard Versa SD-WAN branches. We will then understand how to create a template for a device to be onboarded using the global ZTP. And, finally, we will understand how to verify if the device has been successfully onboarded. And we will also look at common issues that you might encounter, which could cause the ZTP process to fail, and how to troubleshoot them. Global ZTP Overview. Global Zero Touch Provisioning is an automation solution that's designed to reduce manual errors and save time when IT needs to bring new infrastructure online. It reduces the need for IT intervention in the implementation with a quicker turnaround time. It further simplifies the end-user plug-and-play experience, where the user just needs to power on the appliance and connect it to the internet. Versa Global ZTP lets you connect the branch device to the network when the device is powered on. The default configuration needed for the GZTP is added as part of the Versa VOS software installation. The task of Global Pre-Staging Server is to inform the CPE where it should connect for the actual onboarding, and which customer the CPE belongs to. It is a true zero-touch provisioning, in the sense, no service technician is required to visit the customer premise to activate the equipment. Prerequisites. In this section, we will understand the prerequisites for configuring Global ZTP. GZTP requires an internet connectivity with DHCP enabled. Customer has to share information related to serial number of the appliance, country or region where the staging controller is deployed, its IP, or FQDN details, the local and remote authentication IDs and keys. The default configuration must be loaded on the appliance, and the basic checks should be done before the device is shipped. Basic checks include verifying the software version using the CLI command, show system package info. The show system status, CLI command, to verify if all the processes are running on the VOS appliance. Verify that the interfaces configuration are in default, using the show interfaces brief command. And, the show system details, to verify the hardware-related information. If the appliance is not booted with the default configuration, follow the steps shown to load the default configuration. Finally, ensure that the customer's director has the relevant post-staging template, which includes device workflow template, device group, and the device bind data. The workflow template should be in deployed state before activation. In this section, we will understand the scenarios in which the global ZTP would be a preferred method. Unavailability of a skilled technician to deploy the SD-WAN appliance in the site. To reduce implementation cost, and repeat visits to activate due to manual error at the time of activation. At the same time, if the service provider does not support DHCP on the internet link, then GZTP process cannot be used. GZTP process. In this section, we will understand how the global ZTP process works. Once the Versa VOS appliance is powered on, and the internet link connected on the VNI 0/0 interface, the interface automatically gets an IP address assigned by the service provider. Versa appliance will then reach the Versa CA certificate server to download the certificate. After the certificate is downloaded, the appliance device will perform what is called as call home. During call home, the appliance will connect to the cloud-hosted Versa staging controller. Based on the customer serial number and other information provided, we have to create a staging template and a device group. At this point, the device is ready for pre-staging. Next, the CPE will reach the staging controller and perform IP authentication using the Versa CA signed certificate, which was downloaded. Then, the IPsec connection will be established between the appliance and the Versa staging controller. The Versa staging controller will inform the staging server about the appliance. The staging server then pushes the staging configuration to the appliance via a netconf session. The staging configuration contains the customer's staging controller information and the authentication information, auth key and IDs. At this point, two-factor authentication is done, if it is enabled. Once the configurator is pushed, the appliance reboots, and comes up with the staging configuration that has been pushed during the staging process. And, at this point, the appliance will try and connect with the customer's staging controller. The appliance is authenticated using the pre-shared key, and IKE and IPsec processed are completed. The customer staging controller will notify the customer staging server about the new appliance. Now the customer's staging server that has the post-staging configuration of the appliance pushes the configuration to the appliance. After configuration, the appliance reboots and establishes connectivity with the customer's staging controller. The SLAs, IPsec and the MP/IBGP session with the customer's staging controller come up. Once this is done, the CPEs will have established their Dynamic Tunnel Virtua interfaces, or DTVI, to exchange data traffic between the branches. Now we will understand how to do a global ZTP-based provisioning of an appliance. The first step is to have the required configuration on Versa pre-staging server. To do this, we require the following information from the customer. Customer name, region or country, post-staging controller IP of the provider, local auth ID, remote auth ID, device serial number, and the local and remote keys. Use 1234 for both the local and remote keys. Once all this information is available, get in touch with Versa NOC chatbot to initiate the pre-staging server configuration. The chatbot will present you with the following options, and we need to type it on the chat so that the GZTP server can be configured. /NOC infra, this option is to be used if we want to provision a new template on the Versa pre-staging director. /NOC CPE, this option is to be used if we want to provision a new device on the Versa pre-staging director. /NOC reset, this option is to be used if we want to reset the certificate on CA to re-provision the device. And /NOC API, to get supported API details. We will now see how to give these command line syntax as input to the Versa pre-staging server. First, we will see how to use this syntax to create a pre-staging template. To create a pre-staging template we will use the /NOC infra syntax. We then need to provide the country or region, provider's controller IP, local and remote authentication IDs, and keys. Next, we will create a new device on the pre-staging server. To create a device, we will use the /NOC CPE construct. In this, we need to give the serial number of the hardware, the customer name, and the region, or country. Now, we have the configuration created in the pre-staging server, that is, the Versa Cloud-hosted global ZTP server. We will now create a post-staging device template on the provider's Versa director. The second part of the GZTP process is creating a post-staging device template and a device on the provider's Versa director. To create a template, click on Workflow, Templates, and click on Add Template to create a new template. For this discussion, we will create a simple device template with one WAN transport and one LAN interface and a full mesh topology. Since we have already looked at, in detail, on how to create the different templates in the Versa director, we will just have an overview of the same in this section, covering the aspects that are relevant to the GZTP process. Create a SD-WAN post-staging template. Give a template name. Select the organization. Type of SD-WAN topology. Associate the controllers. And choose the appropriate service tier. Next, in the Interfaces tab, note that we choose DHCP option for the WAN link. Having DHCP enabled is a prerequisite for the GZTP process. We can configure the other tabs if the design requires it. For the purpose of this discussion, we are using a basic device template. So, after configuring the Interfaces tab, we will create and deploy this device template. Next, we will create a device group and associate the template. To do this, choose the appropriate post-staging template in the device group configuration, and click OK to create the device group. We will now create the device using the device workflow. Click on Add Device to create a new device. Important thing to note here is the device serial number. It has to match the one given at the pre-staging configuration. Choose the correct device group, give the location information, and then update the bind data information. Click on Deploy to deploy this device. Now, we have to initiate the device onboarding using the global ZTP process. To do this, Connect the internet link on VNI 0/0 interface of the VOS appliance, and power on the device. Once TH device comes up, it will go through the global ZTP stages, which we discussed earlier. The VOS appliance will go through the following stages, before getting onboarded on the provider's staging server. First, the appliance will boot up with the default configuration. Use the show interface brief CLI command to verify this. Next, the appliance will get a DHCP address on the WAN interface. After this, the bootstrapping process takes place. It gets the IP or FQDN of the CA server, and pre-staging SD-WAN controller by doing a DNS query. It registers itself on the CA server, and downloads the certificate. We can view the certificate in the VSMD mode, using the command show IPsec config 0all. Use the command vshconnect vsmd to connect to the VSMD mode. The important configuration to look for here is the certificate and the private key. After reboot, we see that the device has come up with the post-staging configuration. In this section, we will understand how to verify if the device has been successfully onboarded, and the service status. The first step is to check the interface's status using the show interfaces brief command. Ensure that the interfaces are up and operational. PTVI towards the controller should be up for the control path. Check if the interfaces, LAN and WAN, have got the correct interfaces and IP address assigned. Next, use the show interface dynamic tunnels to verify if the branch-to-branch, secure and clear text tunnels. The tunnels should be up between the CPE and the controller, and between the CPE and other SD-WAN branches. The tunnel type, secure, is an ESP transport, and clear text is one without ESP encapsulation. Next, we have to verify the SLA status of the branch. Use the show org tenant name SD-WAN SLA monitor status to verify the SLA status of the branch. The branch should have SLAs established with the controller, and the other branches on all available transport links mapped onto the SD-WAN. The SLAs run on top of the DTVI interfaces. Use the show org tenant name SD-WAN brief to view the list of all the remote branches, and the controllers the SD-WAN branch is connected with. Next, verify the IKE and IPsec sessions with the controller. To view any failure in the IKE or IPsec, append the CLI command to view the respective sessions, with a history argument. This will list out the list of IKE sessions, and if there has been a failure, it will list the reason for the same. In this section, we will look at some of the common issues that could result in failure of global ZTP process. As we understood, GZTP depends on the internet connectivity to reach versus CA server, and versus cloud-hosted pre-staging server. Any issues in internet reachability would cause the GZTP process to fail. Verify if the certificate is downloaded in the edge device. If the certificate is not there, then the GZTP process will not progress. To verify if the certificate is present or not, use the show IPsec config 0all command. And check if the certificate and private key are present. If IKE is not established, and pre-staging configuration is not pushed by versus pre-staging server, check with NOC, and verify if the certificate has been generated properly for same serial number. If post-staging configuration fail, verify the local and remote auth IDs and keys configured in the provider's staging server. Summary. In this module, we discussed how the global ZTP process works, the prerequisites that have to be in place, scenarios where we can use the global ZTP method to onboard Versa SD-WAN branches, how to create a template for a device to be onboarded using the global ZTP, and, finally, how to verify if the device has been successfully onboarded, and few troubleshooting tips for issues that you might encounter.